Okay, hi there. I'm Hao. And this is just another video of me solving random code problem. So longest valid parenthesis. So given a string containing just the opening and the closing parenthesis, we need to return the length of the longest valid well-formed parenthesis substring. So substring means it has to be um, continuous, like a subarray, like a substring. So if we have like one valid here, right, and then one invalid here and another valid here, right? Right? This only counts two, but not four. Okay, so it has to be a substring. So like a subarray, it has to be continuous. Okay, so we're going to see that S of R will only be open or close parentheses. So we can do this in two parts, right? So we can iterate from left to right to keep track of the maximum we can count. So let's see. We can let me find a good example here. We can have yeah, something like this, I think. Okay, yeah, let's do something like this. So when we iterate from left to right, right, we need to keep track of the open and the close, right? Opening and the closing parentheses, there's zero, right? Um, so when we go to the left, right, the close cannot be more than the open, right? So if we have something like this, right, if the close, right, so left to right, 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 if close is larger than open, right, it is invalid, right, invalid, right? And when we go from right to left, if we have so this is an example like this, right? So we go from right to left. If we have more open than closed, right? So right to left, right? Open is greater than closed. These are going to be invalid, right? Because we are iterating for to the left side, right? And we know that we only have one closing parenthesis, but we already found two opening parentheses, so we cannot squeeze anything in here, right? Because we are iterating from right to left. Okay. So as we iterate, right, we can keep track of the maximum, right? The maximum here, the max length is equal to zero initially. Right? So just keep counting, right? If we see an opening, we count one, right? Close, one, right? Open again. So two, right? Open, three, right? Open, four, right? So we just keep counting, right? Um, so when do we update the max? We update the max length when open is equal to close, right? If open is equal to close, then we found a valid pair. Okay, so let's go back here, okay, and try it again. So first we see the open, right? So we have one, right? Now we see the close, we have one, right? Now open is equal to close, right? Which means we found a valid pair. So we need to update the math, right? So one, zero and one, zero and two, right? Because the total is gonna be open, right, multiplied by two, or the close multiplied by two, doesn't matter. Or open plus close, right? So the max is gonna be two here, right? Two, right? And we keep going, right? So open, we found three open, so we can add this one to four, right? And if we found another two close, so this becomes three, right? So open never equal to close, so we just stop, right? We are done. And as you can see, the longest substring gonna be this one, right? The value here. So we didn't catch it going from left to right, right? But we catch it when we go from right to left. So let's try it again here. So we found the close, right? So this is close one, two close, right? Two close, and then one open, right? And then two open. Okay, now open and close are equal to each other, right? So we found a lot of substring. So let's update our max, right? So two is smaller than four, right? Four, right? So update this to be four, and then we keep going. So this is close at three, right? Oh, sorry, it is open, not close, right? It is open. That's right. Yep. So we have two close and three open, right? So now the open is more than the close, right? If open is more than the close, and we already at this point, right? There's no way we can add another. There's no way we can find another closing parameters here. So this is invalid, right? Because open is larger than close. Yeah. So in that case, right, we set the open and close back to zero. Okay, and then we can keep going right to the end. Right now we find one close and one open, right? We just we're gonna find a value pair, so we can pair it 4 and 2, but 4 is larger, so we just keep 4. So that is our strategy there. It takes us ON, right? Because we do it in two paths and constant space. Okay, so we're gonna have our open close, right, and the max length all equal to zero. We iterate from left to right. Okay, if S of I is equal to an open in parenthesis, right? And then we want to increment the open, right? That way we increment the close. Okay, like that. After we increment, right, either open or close, we need to check that if open is equal to close, which means we found a valid pair, so we need to update our maximum node. So max length and then open is divided by 2. Okay. So if close is larger than open. So because we are going from left to right, right? So close, the closing parenthesis cannot be more than the open, right? So if it is more, then we need to reset the open and close back to zero. Okay. And then now we finish left to right. We need to go from right to left, right? And we need to reset our open and close here before we do that. So for let I equal to s of length minus 1, right? I is also gonna equal to 0, I minus 1. So s of I is equal to open, right? And we're gonna increment the open, otherwise we increment the close. We check if open is equal to close. So here it is, we found a valid substring. We update our max length, right? Open is equal to 2. And then else uh if open, right, is larger than close. So now we are going from right to left. If we are going from right to left, open, the number of opening parentheses cannot be more than the closing parentheses, right? If it's invalid, so we will reset open and close back to 0. Right? And then we can return the maximum again. So yeah, that's pretty much it. Let's try that and it worked. Thank you for watching.